Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 16 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1718. Construct the lexicographically largest valid sequence. Okay, so let's read the problem statement first. We have given an integer n. We have to find a sequence that satisfies all of the following. Okay, the integer 1 occurs once in the sequence. Okay, each integer between 2 and n occurs twice in the sequence. Okay, for every integer I between 2 and n, the distance between the two occurrences of I is exactly I only. Okay, so here let's suppose this is one sequence. Okay, so here 2 is appearing. Okay, so next time 2 is should be appear at a distance of 2 only. Okay, so let's say here this is a distance of 2. Okay, so let's suppose this is index 0, this is index 1, and this is index 2. Okay, so 2 okay can appear twice, right? For every integer I between 2 and n. Okay, so all the integers from 2 to n, they occur twice in the sequence, right? So if 2 is appearing at 0, then next time this 2 should appear at this. Okay, so if you calculate the distance between them, okay, so 2 minus 0, distance is 2 only, right? Okay, the distance between the two occurrences of I, okay, is exactly I. Okay, so for 2 the distance is 2. Same way for 3, distance should be 3. For 4, distance should be 4. Okay, of the next 4. All right, the distance between two numbers on the sequence a of I and a of j is the absolute difference of their indices j minus I. Okay, so here 2 and 2, so absolute difference is 2 only, right? So same way for 3 and 3, the absolute difference should be 3 only. Okay, we have to return the lexicographically largest sequence. Okay, and it is guaranteed that under the given constraints there is always a solution. Okay, now what is this lexicographically largest means? Okay, so a sequence A is lexicographically larger than a sequence B of the same length if in the first position where A and B differ, sequence A has a number greater than the corresponding number in B. Okay, so take this example. Here we have 0 1 9 0, and here we have 0 1 5 6. Okay, so 0 and here 0, okay, same. 1 and 1, same. Here we have 9 and here we have 5. Okay, so 9 is larger than this 5. Okay, so this is lexicographically larger than this one because the first position they differ is at the third number, and 9 is greater than 5. Okay, so this is the definition of lexicographically largest. Okay, so I hope that you guys are clear with the problem statement. Okay, now let's understand this problem statement with an example here. Okay, so here n is equal to 3. Okay, n is equal to 3. So here one thing you guys know, that 1 is only going to occur just once. Okay, the integer 1 occurs once, and the integers from 2 to n. Okay, so 2 to n we have 2 and 3. Okay, so 2 is going to occur 2 times and 3 is going to occur 2 times. Okay, so what is the total length here? What is the total length here? So total length, total numbers from 1 to n, if you see, 1 2 3, total 3 numbers. Okay, so 2 into 3. Okay, but 1 is occurring just once, so I can say minus 1. So here 2 into 3 minus 1 is going to give me 5, right? So here 3 is nothing but my n. Okay, so this 5 is the size of this output. Okay, so here n is equal to 5, so simple formula 2 into 5. Okay, so 1 to 5, all the numbers 2 times, but 1 is once, right? So I'm subtracting 1 here. So 2 into 5 minus 1 is 9. Okay, so this 5 is nothing but n, right? So this is going to be the size of my output. Okay, so here see, 1 2 3 4 5 6 7 8 9. Okay, 9 is the size. Okay, so this is important observation. Observation 1, what is going to be the size of my output? So size of my output is going to be 2 into n minus 1. Okay, clear, done. All right, so now here if you see here, okay, let's suppose if we have just if my n is equal to 1, then my output is going to be like this. Okay, if my n is equal to 2, okay, n is equal to 2, then what is going to be the size? Size is going to be 3, right? if my n is equal to 2. So my output is going to be like this: 2, 1 and 2. Okay, this is going to be my output. Okay, so here add 0, 1 and 2. Okay, so 1 to n, we have to use the number, right? 1 occur one time and 2 to n occur twice. So yeah, this is valid. Okay, this is also valid. Now if n is equal to 3, then you can take this example na, n is equal to 3. So my output is going to be n is equal to 3 if I write. So I know the size is 2 into n minus 1, which is nothing but 5. Okay, 1 2 3 4 5. Okay, so here uh, this is nothing but 0 index, 1 index, 2 index, 3 index and 4 index. Okay, so if I place 1 here, okay, and then 3 here, the next 3 will be here only, and then 2 here and 2 here. Okay, so for n is equal to 3, this is going to my output. Okay, so here you see right now there is no pattern. Okay, there is no pattern. Okay, so if you want to write for n is equal to 4, so let's write for n is equal to 4. So for 4, 2 into 4 minus 1, that is going to be 7. So 7, 1 2 3 4 5 6 and 7. Okay, this 0 1 2 3 4 5 and 6. Okay, so for 4 should be here, and then next 4 will be here. Okay, and then you can write let's see if I can place 3 here. Let's see. Okay, 3 here, the next 3 will be I can't place 3 here, right? I can't place 3 because next 3 I want to write here, but this is already occupied. Okay, so let me just remove this. Okay, so if I place this 3 here, let's suppose, okay, then next 3 will be here. Okay, then okay, this is done. Okay, so now next time if I place 2 here, so I can place 2 here and 2 here and 1 I can place here. Okay, so this is output for n is equal to 4. Okay, right? And so you see there is no pattern. Okay, so there is no pattern actually in this problem. Okay, so now how we are going to solve this? How I'm going to write n for n is equal to 3, this is the output. How I'm going to write for n is equal to 4, this is the output. How I'm going to write for n is equal to 5, this is my output. Okay, so let's solve this for n is equal to 5 first. Okay, let me show you the bigger example only. N is equal to 5, how I'm going to fill this. Okay, so my n is equal to 5. Okay, so for n is equal to 5, my first observation is size is going to be 2 into 5 minus 1, which is nothing but 9. Okay, so let me just write 9 blanks here. 1 2 3 4 5 6 7 8 9. Okay, so here this is 0 index, this is 1 index, this is 2 index, this is 3 index, this is 4 index, this is 5, this is 6, this is 7 and this is 8. Okay, all right, so this is done. Okay, and we have to use 1 one time, we have to use 2 two times, 3 2 times, 4 2 times and 5 2 times. Okay, these are the options that we have. Okay, so first of all we need lexicography larger. Okay, so definitely you know that largest number should come to the first blank. Okay, so let's fill that. So first n is equal to 5, n is 5, right? So here I'm going to write 5 first here. Okay, I'm going to use 5 here. Okay, so if I'm using 5 here, so this is given in problem statement that 5 should occur 2 times. Okay, so if I'm writing 5 at a particular index, okay, so next time this 5 where should it occur? So next time this 5 should occur at I plus this, what is this value? Okay, this value is nothing but 5. Okay, add this I plus 5. So next time my this, it should occur at uh 1 2 3 4 5. Okay, here it is at, if you see here, 0 1 2 3 4 5. Okay, at 5. So my formula is going to be then I plus 5, right? So this is the correct formula. So I plus 5 is 5, so next time my 5 is going to appear at this position, right? So if you see here, I'm writing it correct, right? 0 1 2 3 4 5 6 7 8. Okay, so at 5 only I'm writing. Okay, so first I fill 5. All right, so now I have used 5. So what are the options that I have? I have these options now. I can write 1 just one time, I can write 2 two times. Okay, 2 and 2. I can write 3 two times. Okay, I can write 4 two times. I can write 5 two times. Okay, so we need lexicography largest number, right? So I have used this 5. Okay, so I have used it, I have used this 5. Okay, now I'm not going to use it. Okay, so now let's fill this next space, next blank with 4, right? Because I have already used 5. I don't have the any other option of using 5. Okay, so if I place my 4 here, so my next time where I am going to place my 4. Okay, so I plus 4, 1 plus 4, 5. This is already occupied now. This is not blank, this is already occupied. That simply means that I can't use 4 here, right? This simple meaning that I can't use 4 here, because if I'm going to use 4 here, the next time I should write 4 at index 5. Okay, 1 2 3 4 here. Okay, but I can't do that. Okay, I plus 4. Okay, this is nothing but my n. So this is the formula that I'm to apply in a number. Okay, if my I is this, okay, next time this one. So this is first number, this is second number. Okay, so I can't write, so I have to do backtrack now. Okay, I can't use this 4 here. Okay, so I have to do backtrack here. Okay, so instead of 4, what is the next largest number that I can use? I can use this 3. Okay, so if I place this 3 here, so next time my 3 is going to be at I is 1 and 1 plus 3 4. So at this position, okay, I can write 3. Okay, done. So I have used this 3 also. Okay, so now for the next blank, so we have one option to use 4 here. So let's see if I can use 4. So if I place my 4 here, okay, next time my 4 is going to place at I is 2 plus 4 6. So I can place this 4 here. Good, nice, well done. Okay, so here I have used this 4. All right, so now next time I have used 5 4 3. Okay, can I use 2 here? If I place 2 here, next time I can't use, right? If I use 2 here, next time I want to place 2 at 3 plus 2 5. Okay, I can't use that. Okay, so here I can use 1. Okay, so here now next time if only 2 is left now, so if I use 2 here, then next time what I'm going to do, can I place 2 here? So 7 plus 2 9, there is no 9 index. Okay, so this is wrong. Okay, so again we have to do backtrack now. Okay, that simply means that this is not the valid output. Okay, so here I have removed this 2. Okay, here I have removed now before 2 we have placed 1 here. Okay, so I have removed this. So after before this I have placed this 4 here, so I have to remove this as well. Okay, I have removed this. Okay, so now instead of placing 4 here, can I place 2 here? Okay, can I place 2 here? So instead of placing 4, okay, we have placed 4 here now. So instead of 4, can I place 2 here? I can't place 2. Okay, next time I want to place then 2 at this. Okay, so 2 is not the option. Okay, then can I place 1 here? Can I place 1 here? Okay, I can place. Okay, I have used this one now. Okay, so next time here, can I place 4 here? Can I place 4 here? Now if you see, 4 is still left out. Okay, so let's see if I can fill 4 here. So if I use 4 here, so 3 4. Okay, so next time I have to write 4 at 7. Okay, so here I'm writing 4. Okay, done. This is already occupied, this is already occupied. Now 2 is left. So if I write 2 here, so next time I have to write 2 at I plus 6, which is 6 plus 2, so 8. Okay, I is 6 and number is my 2, so 8. So 8 I can place. Okay, so let's see now, is this the correct output? So 53143. Okay, 53143, then 5242. Yes, this is the correct option. All right, okay, so this is the correct approach, right? So this is what we need to do. Okay, so this is going to be my final output. Okay, so this is how I'm going to fill. Okay, so first what I'm going to do, first observation is find the size. So once you find the size, then start with the largest number. Okay, try to fill that. Okay, first space. Okay, so since this number is from range 2 to n, okay, so we have to use it twice. Okay, so you have to fill first number and second number. Okay, for this. Okay, once you fill this, then move to the second blank and try to fill it with the max number which is available, which is not used yet. Okay, so try with the 4. So if it is not possible to fill that data blank with 4, try to fill it with 3. Okay, same way, if 3 is okay, 3 is possible, then fill the first and second with that. Okay, but if it is not possible, then we have to move to 2 and 1. Okay, but if this way, this path is not correct, so move back, try it some other way. Okay, instead of using here 4, you can use here 3. Okay, so you have to follow the path. Okay, so this is what we need to do. Okay, So we have to just do the backtrack, okay, until we find the correct output. And always we are going to start with the max number first, okay, because we need the lexicography largest number. Okay, so once we are able to fill all this, okay, once we are able to fill all the indexes, definitely I'm going to return true. Yes, we have filled it completely. Okay, that means that our this largest number we have found it, because we are already taking care of the largest number first. Okay, right? So now let's move to the coding part, and I'm going to write the same story whatever I have explained now. Okay, so now let's move to the coding part. Okay, so first of all, here what you need to do, you have to calculate the length. Okay, so here int length is going to be you can write it 2 into n minus 1. Okay, this is going to be the length. All right, now create one result array. Okay, and you know the size of this result array. Okay, new int, and here you are going to pass length. All right, and then we have to check whether we have already used this particular number or not. Okay, so here I'm just going to create one boolean type used array. Okay, and here what is the going to be the size of this one? So size of this one is going to be n plus 1. Okay, since we are using the numbers until n, right? So this is going to be the my used array, and here I'm just going to call the backtrack. Okay, I'm going to call the backtrack method. Okay, so in this what I'm going to do, I'm going to pass the result. Okay, I'm going to update this result in this backtrack method. Okay, and here I'm just going to keep track of the used numbers. Okay, and here this is going to be my the starting index, and here this is going to be my n value. Okay, right? And I'm expecting this backtrack method to give me the final result. Okay, it should update the result value. Okay, result array, it should update this backtrack. So here I'm just returning a result. Okay, so now let's write this method. Okay, backtrack. All right, so here private, okay, and here boolean backtrack. Okay, and here you have to write int result. Okay, and here boolean used. All right, and here index, and here int n. Okay, right? So here once you reach to the end, okay, so if your index is equal to result dot length, okay, then in that case you have to simply return true. Okay, if result of index, okay, so if this is not equal to 0, okay, if this is not equal to 0, all right, then in that case we have to return again. Okay, so we have to here, so from here simply I'm going to return backtrack, and here I'm just going to pass this result used, and here I'm just going to update the next index. Okay, let's fill the next index, and here and okay, so we have to move to the next empty position. Okay, that's the simple meaning of this line. All right, then after that here we have to just fill the largest number first. Okay, since we are going to get the lexicography larger number, right? So here for int num is equal to n, and your num, okay, num, it should be greater than equal to 1, right? And here you have to write num minus minus. Okay, done. And now inside this we have to try the numbers from n to 1, right? Lexicographically largest. And now here I'm just going to check if we have already used the number in past or not. Okay, so if we have already used this particular number, okay, then in that case simply continue. All right, but if we haven't used this, okay, so here I'm just skipping if already used. Okay, but if we haven't used that, then we have to find this next index also now, where I want to fill this. So second index, I'm going to just get the second index. Okay, second index, how I'm going to get? So if my number is equal to 1, then there is no need of second index. Okay, then second index itself is going to be index only. Okay, but if the number is not equal to 1 but it is 2, 3, 4, 5, okay, for n is equal to 5, okay, so the next position is going to be index plus num. Okay, done, right? So here now check if we can fill this second index or not. Okay, so if second index is less than res dot length. Okay, in this case we can fill and the result, okay, this of second index. Okay, result second index. Okay, if it is equal to 0, that simply means that we haven't filled this, right? Initially by default value is 0, right? So in that case we have to update. So first I am updating the index with the num. Okay, done. Then if number is not equal to 1, okay, number is not equal to 1, then we have to fill the result of second index as well. Okay, so result of, here I have write second index. Okay, and I'm going to fill it with num also. Okay, so here index and second index both I'm filling with num. Okay, and I have to mark that this I have already used this number, so used of num I'm going to mark it true. Okay, we have used this. Okay, done. Okay, so now here I will just check if backtrack. Okay, I'm going to call this backtrack. If backtrack, and here I'm just going to pass this result used and next index plus 1. Okay, and here n. All right, and here what we are doing, we are, if the sequence is valid, then we have to return true. Okay, so here I'm just going to simply return true if the sequence is valid. Okay, and in case of backtrack we have to reset the values. Okay, if we are going to do the backtrack. Okay, so here it is going to return true. Okay, if this is valid. Okay, if the sequence is valid, then it is going to return true. Otherwise we have to backtrack. Okay, we have to reset the values. So simple, just copy all these. Okay, so if in case of backtrack, so this index again I'm just going to update this with 0. Again, if number is not equal to this, then again I'm going to fill this with 0, and here I'm going to reset it to false. Okay, this is for backtracking purpose. We are doing the backtrack right in our code. And if no valid sequence is found, but as per the problem statement there will always be valid sequence. Okay, so but in the end just write here return false. Okay, if no valid sequence found. Okay, that's it. So now let's run the code and see if any code is. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.